Welcome everyone to our first Skills 101 exclusive session. I'm your host, Jessica Pasqualo, and today we're diving into a truly exciting topic, migrating your on-premises database to the cloud. We have an incredible pair of experts joining us today, two of my personal favorites, Amit and Dennis, who are not only skilled at navigating cloud migration, but they also possess amazing insights that can transform what may be potential hurdles into smooth sailing. Now, without further ado, Amit, Dennis, the stage is all yours.
Hello, and welcome to this session titled Model Before You Move. My name is Amit Parikh, and I'm joined by my colleague, Dennis O'Sullivan, and we're here to talk about a use case extending Oracle to Snowflake with confidence. Today, we're tackling a challenge that's fundamental to any data-driven organization, and that's a data migration. But we're not just talking about moving data from point A to point B, we're also wanting to talk about how to do it right. Too often, migration projects are plagued with unexpected issues, and that's what we're here to talk about. We're here to help you avoid those types of things.
Yeah, and just to come in there, this is potentially a massive problem. If you think about what's at stake, data is the lifeblood of most modern organizations. And when a data migration goes wrong, it's not just an IT issue. So, end users are impacted, customers are impacted, automated processes are impacted. So you end up with increased cost, reduced revenue, which affects your underlying ROI figure. And Gartner reported that a staggering 83% of data migration projects fail or exceed their planned budget and timelines due to poor planning and governance. So this is essentially critical when moving to a native cloud platform such as Snowflake, because unsuccessful migration due to maybe a misconfigured schema will have a direct correlation on how much your company pays every month. So you're not just dealing with performance issues, you're dealing with cost issues as well.
Exactly. So to guide you through a successful migration, we'll be using a real-world use case, moving data, as mentioned, from an Oracle database to Snowflake, and we'll demonstrate how Quest solutions, such as Irwin, SharePlex, Foglight, and even Toad Data Studio, provide a comprehensive approach to making this transition as smooth as possible. We want this to be interactive, so please participate and ask questions.
Yeah, this might be a good point to get the audience involved and do a pulse check with the audience's experience.
Yeah, here's our first question for everybody. What's one of the biggest risks of migrating data without a clear plan?
Okay, so as those answers come in the chat, let's start at the very beginning and understand what we have before we move. And data modeling is absolutely essential here. For example, IDC states that 65% of failed migrations are due to schema mismatches and poorly documented data sources. So without a clear picture of your existing landscape, it's kind of going on a continental drive without first planning out your journey.
Yes, and in this journey from Oracle to Snowflake, we're dealing with the database that supports critical business functions. It's a retail database. It has customer transactions, product inventories, user or account information. So imagine trying to move all of that without first understanding how it's all connected. I think we'd say we'd run into some risks. First risk being, while both databases are powerful in their own right, there are fundamental differences in terms of how they handle the data types. So we can't as a team just assume that everything's going to translate perfectly. And databases, many of them rely on relationships, such as referential integrity, foreign keys. So for example, there might be unexpected behavior in the new environment if we don't plan for those differences. Additionally, do we really need to migrate everything? A migration is an opportunity to clean house, but you need to know what you have in order to make those decisions.
So this is where Irwin comes in. So as you can see on screen here, Irwin gives us a visual representation of our Oracle database. So Forrester research indicates that enterprises leveraging data modeling tools reduce migration errors by 40%. And by using Irwin, we can proactively identify those data type transformations, dependency issues, and potential schema mismatches before we even start the migration. So here on screen, I have reverse engineered an Oracle schema. There's a lot of things you can do before we move on, but one crucial aspect is looking at data type transformations. So under my data type standards, if I go to properties and look at my mapping, so I've set up an Oracle 19c to Snowflake mapping. If we look at some of these mappings, which are really critical. So for example, if you're dealing with the number data type in Oracle, there's probably a few different decisions you need to make there. For example, if you're using it for ID fields, primary key fields, you probably want to move to integer because Snowflake deals with integers better. But if you're going to something like a monetary value, which is going to have a decimal in it, you're better off going to the decimal data type. So there's some decisions to make there. Also, it's recommended if you're going from a data type in Oracle to use the timestamp in Snowflake. It's far more flexible, especially dealing with time zones, and it's also better for analytical processes. So there, and obviously something like varchar2 down the end here, there isn't really an equivalent in Snowflake, so it's recommended to use string. And there's no need to specify the length in because Snowflake automatically optimizes storage. So you don't have to worry about that. So they're just some of the transformations that I have done on this particular schema. Now, the next thing I've done is I have derived a new model from this. So I did this earlier. I derived a Snowflake model from my Oracle model, and I've made some changes to this model. Probably the most apparent one is the lack of relationships. Because Snowflake doesn't enforce referential integrity, I didn't think there was any point in mapping it out. You can include relationships, they're useful for visualization purposes, but I find they can become confusing for end users that might think that referential integrity is actually enforced when these relationships are purely informational. I've also done some data type changes, such as my recommendations of using integer for ID fields and decimals for monetary fields. And because I don't have my relationships mapped here, the final thing I did is I created a logical diagram. The logical diagram gives me a few kind of benefits. First of all, I can identify my relationships. I can also make my entity and attribute names a bit more descriptive, so it makes it easier to understand. And we'll see later in this presentation how we can map our logical diagram here to our physical Snowflake and Oracle databases. And before leaving Irwin Data Modeler, really one important step is I've saved all these models into the Irwin Mart. This is a centralized repository that allows for collaboration across the team. So as myself and Amit need to make changes to our Oracle or Snowflake or logical models, we can do so off the shared versions in the Mart. I can then push those out to Git. For example, if I want to take my Snowflake model to generate my Snowflake schema, I can hit my schema button here. And if we look at the preview script, it's generating all these objects in my Snowflake schema. I can save this file, I can push it to Git, or I can generate it directly in my Snowflake schema. So at this point now, I have a empty Snowflake schema, but structurally it's not identical, but the same as what I have in Oracle.
Dennis, real quick, I wanted to ask you, in terms of preparing the environment, the target environment in Snowflake, how would you go about doing that? Is there another Quest solution that could assist with that?
Yeah, I suppose this comes to the tricky part. How do we get the data across the Snowflake? The easy answer is there is no easy way to do this. There's no easy way to move large amounts of data from an on-premise solution into a cloud provider. There's many options. One option would be to use Toad Data Studio. So Toad Data Studio can connect to multiple data sources, including, as you can see here, my on-premise Oracle database, as well as my Snowflake environment. And we have an import-export utility here. And if I launch this wizard, you can see it just asks me, where do I want to get the data from and where do I want to put the data in? So I'm going to specify my on-premise Oracle database as my source. And I'm going to select my Snowflake environment as my target. The wizard then will ask me which tables I want to do. I'll show you just doing it for a single table. So I'm selecting my customers table in Oracle.
Sorry, I don't have a good joke to tell at the moment. See, that's what usually happens.
Yeah. So at the next step, it asks me, do I want to put this into an existing table or create a new table? Now, Erwin has already created those tables in Snowflake, so I'll select an existing table and select my customers table here from the list. And you can see, based on names and data types, it has matched up the columns. Now I can overwrite this if I wish. Go to next here and kind of add new tables. You can also bulk load these as well if you're dealing with a lot of tables, but I just want to show you how you do that one at a time. So once you create your list of tables that you want to bring across, you can decide whether you want to import it right now, import it later, or create an automation script that can do it at a scheduled time. I've already preloaded my data, so I'm just going to hit cancel here. But that's quite a simple way of extracting the data from your on-premise Oracle database and pushing that data into your pre-set up Snowflake environment.
Well, great. Well, as you can see, modeling up front with Erwin allows us to plan for these. I mean, you showed us the transformations. This should ensure us a smooth transition and hopefully avoid any mid-migration failures. So thanks for showing us that, Dennis. Let's go ahead and check in with our audience again, and let's just get a quick pulse. So audience, so why is data modeling important before a migration? Perhaps you could share from your own experience or perhaps something you've learned just over the last few minutes.
Okay, so we've modeled our data. We've done that initial instantiation of the data, got that data out of Oracle into Snowflake. Now, of course, in the background, Oracle is still a live production system. There's still data changing in there. So we need to set up a replication so we can synchronize that data. Now, Accenture reports that a huge 70% of enterprises experience significant downtime during migration, often due to inadequate replication strategies. Downtime translates directly to lost revenue and disrupted operations. So that's why we're going to use SharePlex, which is designed for real-time replication, which requires minimal downtime in terms of switching from Oracle to Snowflake.
Yes, thank you, Dennis. And so before I get into what SharePlex does and how it's architected and how we've set it up here for this use case, it's important to note that your traditional ETL-based migration options, they oftentimes use a batch mode approach. This means that you're extracting data, transforming it, loading it into chunks, and then you're finding an off-peak window of time in order to make that happen. So there's a problem. You risk missing real-time updates, and you always need some sort of cutover window. So with SharePlex, the approach is different. What we're doing is we're providing continuous replication of those Oracle transactions, also Postgres in terms of a wider use case, but for this it's Oracle, and to Snowflake, right, as the target. So the benefits are huge, in that SharePlex is capturing changes efficiently without bogging down your source system. And because the data is constantly synced, you don't need a long cutover. You could switch over with minimal disruption. And it has built-in mechanisms to handle conflicts and ensure the data integrity, even if issues arise during the actual process itself. So what I'm going to do here is quickly talk you through the architecture. We'll kind of work from left to right here. You can see that the SharePlex itself is connecting directly to Oracle redo logs. So it's not the database engine. This is a non-intrusive change data capture. And what it's doing is it's capturing the inserts, the updates, the deletes, those changes in real time. So the advantage is there's no triggers or changes within the Oracle schema. There's minimal performance impact being seen. And then your queuing is taking place where changes are stored temporarily in a post queue on the source server. And this acts as a buffer to ensure orderly and reliable delivery, even during network hiccups. You have the export and import, that what we call the transport phase that you see here in the middle. The captured changes are transported securely over the network from the source to the target system. SharePlex supports encryption and compression of the transported data, which is efficient for hybrid cloud configurations for replication. So this is where replication moves from your on-prem Oracle environment to your cloud target. And then finally, the post process, you can see the SharePlex utility is transforming Oracle changes into a Snowflake compatible format. And what will happen is that the data will land, typically it lands in a staging area. Like we obviously have a schema that we've already set up to stage this data that's being replicated. I'll talk a bit more about the post-processing. But there are other ways that you can move the data into the staging area as well. So for example, some folks might use Snowpipe or Snowflake tasks to ingest their data into Snowflake tables. So you see a decoupling of the replication from the Snowflake ingestion, which allows for the scaling and the transformations to occur. So let me move a little bit further here. You'll get these slides as a takeaway. So we actually have a configuration file that's worth mentioning here. Dennis, just chime in if you have anything to add. You can see it's very simple in its design. You have a breakdown on the right. I'll just quickly mention that identifies the source and the target. There is a section for the actual table mapping. You'll see on the left-hand side is it's your source, while on the right-hand side these would be the target objects that are mapped to it. So there are some considerations that you'll make when you go through this file. This is certainly not the only way you can design this. There's some wildcards and there are other special characters that allow you to, to build a more robust configuration script.
The configuration file is quite flexible. You can replicate at a schema level, so you can just specify your source schema name and target schema name if the names of the tables are the same. As you can see here, you can replicate at a table level. So again, you can specify the source and target table names. Again, useful if the table names aren't the same. You can also replicate at a column level or a row level. And you can use any combination of those as well. So it's quite a flexible configuration file. And this is the one single file required for configuration of SharePlex. Once you create this file and activate this config file, that's it. That's as simple as the setup for SharePlex is.
Yeah, and I introduced this as well. This presentation, we talk a lot about model before you move, and it's the important emphasis, the theme of this presentation. And you saw earlier how Dennis showed some of the options you have within Urban Data Modeler when it comes to transformations of those attributes, in the physical model, those columns, the data types. So there's a sort of a balance between how much you do early on in modeling and how much you may or may not have to do post-processing. So I wanted to illustrate this slide because generally speaking, you're staging your data after it's moved into Snowflake. There's probably going to be a final destination for that data where the data is either cleansed or perhaps other types of post-processing tasks will take place. So let me just show you here. So this is the data that we're working with in this presentation. It's an online store, and you can see these are the different types of tables that we have there. These are the likely transformations that will have to take place with this data, and some of these have already been mitigated with Urban Data Modeler. So it's very important to note that the more you do up front, the less that you'll have to do at the tail end. Then you can concentrate on, for example, your post-processing to be for, the very specific things that are necessary, right? Like, for example, like maybe localizing currency formats, or making sure data is obfuscated, ensuring like, privacy and security, or maybe some specific cleansing tasks that need to be done. So I just wanted to make a quick note on that. All right. I think we're probably good for another check-in, but hopefully you see here, this is why Shareplex is the preferred choice for industries where availability is absolutely non-negotiable. Specifically in retail in our example, but also finance, healthcare, any businesses that cannot afford any sort of downtime. So we'll do a quick check-in. What is one advantage of using Shareplex for data migration? Perhaps you guys can think of something. Let us know. So we've moved the data. The job's not entirely done. We now need to make sure that everything is running smooth in this new environment. So the industry reports, McKinsey that is, that a staggering 60% of cloud migration failures are attributed to a lack of real-time observability. So the adage goes, you can't fix what you can't see. And in the cloud, performance issues can quickly spiral out of control.
Yeah, this is where Foglight comes in. So if you're not familiar with Foglight, it provides that critical real-time database monitoring and observability. It's not just about knowing if things are running, it's about knowing how they're running. So Foglight tracks stuff like query performance in both Oracle and Snowflake, so you can do a comparison in your source and target systems. Replication lag, so how quickly are changes being synced from Oracle to Snowflake? Is there any delay that could cause data inconsistencies? And I suppose a high-level system health metrics, CPU, memory, disk usage, all the vital signs of your database systems. So are resources being utilized effectively? Are there any signs of overload? Things like that.
And Foglight goes beyond just showing you those telemetry, those metrics. It's anomaly detection, the capabilities that are built into the solution that enhance the inferencing that goes on with problem solving. So, for example, in an environment like Snowflake, compute resources are oftentimes billed based on usage. It's not often, they are. So when you see a spike in Snowflake compute usage, Foglight will alert you. The alert that we're seeing here is on contention, an actual lock that's taking place. What I can show you here is that you have these built-in alarm templates. So when you think about being proactive and trying to anticipate these issues that could affect the cost and performance of your Snowflake, Foglight already has 18 of those built-in alarms, and you can see here credit consumption is one of those at the warehouse level. So when we start to deal with those issues, so for example, like some of the issues that I showed you earlier, like the contending issue here, the lock that's actually holding a resource. I mentioned the inferencing, this time that you spend in actually researching what the problem is, the context of the problem, and also the remediation, of course. So you can see with the integration of generative AI and access to a language processor, you'll actually see that Foglight is actually producing much of what you have to do manually through your own inferencing efforts. So again, the root cause analysis, steps on how to troubleshoot the issue. In many cases, it'll point you to how to use the product better. And of course, some substantive information, pointing to, industry reading, for example, in this case, Snowflake documentation. So the root cause analysis, I think, is going to be greatly improved for us in this situation. the other thing is that when you're planning a migration, it's very important that you have a handle on the distributed load, that's coming into that newly built system. So what I mean by that is that here we could take a look at warehouse consumption, and we can break down. So for example, I have this is a warehouse here, and you can see a breakdown of the different types of query types that are being utilized. So I'll go to a busier warehouse that we actually have here, and you can see the query load averages. You could see the amount of data that's spilling. So that means that that's an inefficient use of memory when it's spilling to disk. And then you also have here failure rates. The other thing that you can do is you can hone in on parameters that are somewhat highly tunable. Parameters, not so much parameters, but metrics that are key performance indicators that are highly tunable. So for example, overload in queue times, transactions that are blocked. Anytime you see these values above 0, and you can see these are measured down to the less than a second. But when they're above 0, that means that you have insufficient capacity generally, and you might have to think about provisioning more resources. So to make the art of query monitoring easier, and queries are the customers of our data, so as we introduce more workload into our Snowflake target, we would want to know where the impacts are coming from. What the impact column represents is generally how much time or how much wait time that particular transaction is holding against its target. So not only are we looking at high cost, but high impact. Impact equates to cost in Snowflake. So these are a couple of things that you can do with the solution. I mentioned replication lag. I would just come out and say that you can actually use Foglight to pull in like custom telemetry. So for example, as you insert a row into Oracle, you could grab the timestamp for that row. And then on the flip side, you could do the same thing on Snowflake. Once you have that telemetry, you could pull that in a number of different ways into Foglight. One is through the use of a script agent, where you could run your own custom code. As long as there's a standardized output that it can ingest, you can then store that telemetry, and you can actually use this solution to calculate the replication lag for that Oracle to Snowflake pipeline. It's not built in out of the box, but it's something you can definitely do with the extensibility options that are built into this tool. For those of you that are curious how this all works, the Foglight architecture is agentless. Just understand that the collections that are taking place against our target database instances, in this case, it would be our Snowflake instance. That's where we're primarily concerned about the performance, but we would also be able to capture any other information in our environment through a JDBC style or a remote collection from that server. And then that information is pulled continuously, stored and harvested into a unified repository. And then you have a server software that sort of pulls all that together, and it allows you to have the user experience that you've been seeing here the last few minutes. So without further ado, we'd like to ask you guys, why is it important, or why is monitoring data important in a migration? Why is judging or assessing performance during a migration so important?
Okay, so the data is in Snowflake. It's being monitored, but we still need to validate its integrity, ensure its performance as expected. Data Governance Institute study found that 35% of cloud migrations result in data inconsistencies due to improper validation. You can't assume the data is just going to magically arrive perfectly. That's why we use Irwin DI and Toad Data Studio to validate the data.
Yeah, and so real quickly, what I'll do is I'll validate that we'll validate a couple of things here. So first thing we want to do is ensure that the replication that's actually taking place with our Shareplex utility is actually working. So we'll test that out, and what we're going to do here is simply insert a new record into the suppliers table. And you can see I'm connected here to the Oracle database. This is the source system. So I'll execute this query, and then what we can do is quickly do a compare to check and see if we have records that are similar, right? We have an equal amount of records on both sides. Let me go ahead and do that real quick. Okay, so what we've done here is we've inserted the row on the Oracle source table. And what I expect to see now is if I go over and check the target Snowflake database, let me just make sure the connection is proper. And there you can see the new record. So just to quickly recap, one of the quick things I wanted to do here. So in order to validate this system, to validate that the replication was taking place, you can see we added the additional record here on the Oracle table, the suppliers table in the Oracle source schema. And then moments later, we were able to see that record here within Snowflake itself. I'll just switch the connection context. And you'll see that record is over here. So that's just the suppliers table. We also want to check the integrity of the entire schema. So one convenient method to do that in Toad Data Studio is with the data compare. So I actually have that already set up. You can see that you could find that up here under compare, data compare. What I've done is I've set up a connection here to the Oracle source schema, and I have a connection to the target in Snowflake. I'll just kind of refresh this so you can see. And now it's going to go through each and every one of the objects, as well as all of the values, all the records, if you will, and perform that comparison. So in a moment or so, we should be able to validate holistically if there are any different records. So at the top, you're seeing the whole tally. And right now, there are 0 rows different. Or you can just do it this way. So Dennis, I think we have what we need here. We not only proved that the replication seems to be working, we've inserted a couple additional records, but we're also ensured that the schema is valid, data is identical on both sides. So what I'd like to do is pass it over to you to talk about now how can we expose, now how can the business use this data now that's been validated, at least up until this point?
Yeah, sure. So what I have on screen here is our Irwin Data Intelligence suite. And we're looking at our data marketplace. So I have a system called Online Stores. I'm just going to look for systems. I have it set as my favorite system, so it always appears on the top row. But you can see the other systems that we've currently configured in our data catalog as well. So I'm going to look at our online system. You can see here I just added a brief description as to what this is. And there are a number of environments within this system. So I have an on-premises environment, which is Oracle-based. And you can see Amit is the data steward of this as well. You can see a full audit history. And you can explore the individual tables. And I can look at the cloud system, which is my Snowflake environment. And I'm going to look at the lineage here as well. So what I've set up for my end users is just a mapping, a very simple mapping from my, if I just pull this up a second. And we'll come back to my logical models in a moment. But I just have a mapping set up from my on-premise Oracle tables to my Snowflake cloud tables. Now, in my case, it's quite easy because the table names and the column names are largely the same. But if they aren't the same, it's quite useful just to be able to map those. So I can look at maybe something like my payment method and map that to the column that originated from in my on-premise system. This could be quite useful as well because you might be bringing across all the data from Oracle. You might be bringing across maybe the last 5 years worth of data. And if you ever need to go look at some of the legacy data, you may need to go back into that on-premise Oracle database for legacy data. And it can be quite useful to just map that out as well. Also, if you think back to earlier in my presentation where I created a logical model, and I can include my logical model in my lineage as well and map my logical model to my physical Snowflake data model. So this is look at the actual data model within live Snowflake. And again, if I want to understand what a particular maybe order ID is, I can get a good understanding of that from my logical model. So when someone's creating, BI reports or anything like that, they can look through the logical model, find the easily understandable table names and column names here, and then find the physical attribute that they need to grab from the Snowflake environment. So that's quite a useful view as well. This marketplace also allows them to, essentially shop for the data sets. I have access to this data set, so I can, browse all the data. I can see the full lineage and all that. But another person, me, could come in and log in and request access from me to access to this data set. So it's acts as that centralized metadata repository, all built on a data catalog that allows you to, come in and have this shopping style experience where you can request access to data sets that have gone through, governance, they've gone through curation, gone through data lineage, as well as data quality checks can be added in here as well.
Great. Thanks, Dennis. I appreciate that. So let's check in with our audience one last time. So I'll expand this question a bit, but what does Toad Data Studio help with post-migration? I'll even go as far as saying, how does Irwin Data Intelligence or Irwin DI help with post-migration? Anything that you've learned in the last few moments would be great for us to hear. All right. So let's bring it all together. We've walked through a complete data migration, and here are the key takeaways. Using tools like Irwin to understand your source data and prevent those costly surprises. Solutions like Shareplex minimize downtime and ensure data integrity through the entire migration process. And implementing robust observability tools such as Foglight ensures a smooth transition and continuous ongoing performance. And using tools like Toad Data Studio ensure data that has the integrity, and it also allows you to maximize your query performance in your new environment. You also notice that with Irwin Data Intelligence, your ability to create trust, ensure quality, reliability around the data, and democratize the data is there as well.
Yeah. And this model before you move approach isn't just a suggestion. It aligns perfectly with the best practices from industry leaders such as Gartner, Forrester, and IDC. It's about ensuring that your migrations are efficient, reliable, and ultimately cost effective.
And now we'd like to hear from you. And as promised, we're about to start our Q&A session. Please feel free to interact with us. We'd love to hear from you guys. And also take a look at the future schedule as well. We have some interesting presentations coming up later this year.